Hello everyone. Today I am going to start a new series after learning the Python fundamentals. So far I have had tutorials on Python fundamentals where I emphasized functions, control methods, randomization, list comprehension, loops, sequences, and series. From today onwards, I am starting a data science series from the beginning, from the very beginning, from scratch. So this will be towards data analysis, data science, faculty of the Python. Data science, data analysis, division of Python functionalities. So for that, we will have Pandas and NumPy as the main libraries to carry out that. So let's start from the beginning, from the scratch. So open your favorite text editor. Mine is VS Code, and create a file, project folder I have here, and then let's create the virtual environment before creating this. So we need to get a Jupyter notebook in the VS Code, which you can do by doing ctrl+shift+p, and here select create new notebook. Okay, you see that? All right. So then select the kernel. What we're going to do? Python environment. And under that, we're going to create a virtual environment. So let me just go. Once it says created, it's still saying creating environment. Once it says created, then we can go ahead and do that. So here, Python 1, untitled Python. So we can let me get the VS Code in here. Okay, import matplotlib .py plot pyplot as plt. Okay, those will be our imports. Once we have done that import, let's run it. Run this. Yeah, it came checkup. Checked. That means the importation was done. So let's change the name of the file. We will change that name from untitled to title by saving it. You see here? Now, I'm going to just put it script name, okay? And save. You see now the name had changed to script. Okay, so now let's proceed. Today I am going to explain and show you the central idea in statistics. That is so profound that all data analysis, data scientists, machine learning, all the areas of data analysis are applicable to this central idea. The central idea is normal distribution. As you know, normal distribution plays such a crucial role that we can set confidence interval with it. We can see the spread. We can see like 68% 95%, 99.7% coverage. If you want to cover the large area, you need to take a 99.7%. If you want to be precise, a smaller area, smaller spread, then you can do with 68%, which in other words are called mu sigma values of 3 to 1, okay, standard deviations. So this normal distribution is very central. So that is what I am going to show you, creating from scratch with using NumPy. Okay, let's go ahead and start with doing that. So here np.random seed 42. You can put any number. I'm just saying this, the classic 42 case. So this I am doing seed because with seed, the random numbers will persist. That means no matter how many times you run the random number, it will persist. Otherwise, it will not persist. That means I run random numbers, I get one values. You run random numbers, you get another values. Even within the same company, another machine, another PC, another laptop will show different. So that to get uniformity for debugging purposes and getting the uniform result, we need to put this seed function. Okay, so with the seed, now we go random numbers is just variable. How do we get random numbers equals np dot random dot rand n. Okay, let's just put 1 to 100. All right, let's put 1 to 101 so that we have 100 things. So with this, if I just run random numbers, let me show you. If I just run this, let's go ahead and run this. So I need to make it that. Now, if I just run the random numbers, you see, we get this random arrays. We are not looking for random arrays. We want to get the random function. So for that, we get rid of this random numbers because we don't need that. So let me just cancel that. Let me turn that into function so that we get the, not the array, but the function. Okay. So def generate random numbers. See, this is the function. This is the function. Once you are proficient in Python fundamentals, all these things come. Location equals 50, just default values. Scale, location is for mean, scale is for standard deviation. Scale equals 15, and size is for the sample size, the n. How many observations? What was the size of numbers? Size equals 100. Okay. So that is the definition. That's the function. And return np.random.normal. Okay, with those parameters, log, scale, and size. All right. So once we have done that, let's get rid of that. Okay. Now let's run. I'm going to keep writing. Let's convert that into create data frame. Now you see here comes the pandas to create data frame. So pd dot data frame. So what we're going to put in the data frame? The function that we created. Generate random numbers. Okay. And here in this, now we can put the actual value that we want. Log equals 50. Let's put the mean 50. Equals, let's put it, still keep 15, but size. See the size, we go to 1000. Sample size, we increase to 1000. Okay. Now, it's not done. We need to put columns. Columns equals what we need to, what is in the column? The values. Okay, values. All right. So we have that. Once we created this much, all right, let's just print them. Print df normal dot head. Normal dot head. Let's see 5 values. Okay, df normal. So we don't have this defined here, you see. So we're going to data conversion, that line going to put in a value called df normal equals. Okay, so to show you, I can put that a little down here. Okay, so you see now df normal dot head. Now once we run this, let's run this. You see the values are 5 values with different random numbers, 5 random numbers. Okay, so similarly, if you want to see, print df normal, that's the name of the data frame, that describe. Okay, if you want to see basic statistics, you do this. Okay, now here you will see. Look, see here, mean, standard deviation, minimum value, maximum values, quartiles 25, 50, 75. So you see that. That's how we create it. Now let's print a few things like print. Let's print the mean value. Mean equals df normal. Remember, that's the name of the variable that we have data frame. Df normal of values. Okay, values. The mean, I'm going to show you just how we can mean. I'm just going to show you in 2 decimal places. Okay, 2f, that is mean. Let me same way show you the standard deviation. Okay, mean. Here I'm going to show you standard deviation. Standard deviation. Okay. So what is this? Oh, here I forgot to put the n because I want to show that into separate line. So here we can show standard deviation as well. All we need to do here is, instead of mean in the second line, std. So now see here, once we run, we will get mean and standard deviation values. See, mean 50.72, just like here. Standard deviation 14.74. See, 1474. Okay, so one more thing I want to show you. Let's show this in pictures. Let's graph. Okay, for that, plt.figure. plt.figure. Let me scoot it up a little bit so that we can show. Big size equals, let me give you a size of 15 and 6. 15 width, 6 height. plt title. Let's give the title of the graph. The title is going to be a normal random distribution. Okay, that will be the title. Now, df normal that of values dot hist. We're going to show histogram. Hist. Okay, bins. Let me, the basket I will make will be 30 because we have large sample size, so 30 should be all right. Alpha equals 0.7, comma, color of the plot green, comma, edge color equals, say, black. Okay, that is the data frame attributes. Let's go ahead and plt.xlabel. We need to label x side. Let's xlabel plt.xlabel. What is going to be in the x label? Values. Okay. Similarly, we need y label, right? plt.y label. What will be in there? Frequency. Okay, once those labels are done, do we need some grid? Let's put some grid within the figure. plt.grid. Say true. Alpha equals 0.3. And plt.show. Okay, let's show that. Okay, so if I did not make a mistake, or there are no typos or things, we should be able to get this all graph as well. Okay, so we should get the result. For that, I'm going to run all. Okay, here is some errors. I can see the graph is coming, but here is some error. df normal values dot hist. What was the error? Let me rewrite this line. I am not sure why. What is the cause of the problem? df underscore normal Okay, df normal of values dot hist. Here bins equals 30, color equals green, alpha equals 0.7. Okay, let's just run this and see. Yeah, you see here. So that was the function. That's the normal distribution. As you can see clearly, see normal random distribution with sample size 1000. You see bell-shaped curve. Okay, you can see here. If you have mu, which is mean, is falls within the 68% of the distribution, it will be like this part, just within this part. If 95, it will be this part. If 99, it will go way up to the tail and this. So if you want to cover the large area, if you want to have these sample numbers within that, you need to pick up the larger mu, larger spread. You will have a larger distribution of numbers. Okay, so larger the number of sample, smaller will be the distribution. So this is one of the fundamental statistical ideas that have profound influence on the data analysis, data science field. So I wanted to make this start with this little random generation of data and its implementation and turning into the data frame with the use of NumPy as well as Python. From the next video, I will be showing you the regular way of creating, analyzing data, which is reading the data files either in, say for example, Excel sheets or CSV files, comma separated variable files, which are the most popular ways of data already created. You import them and then you read, you pre-process, analyze, and you do exploration with various kinds of plots and all that kind of good stuff will be coming from the next lessons. This is the start of data analysis, data science activities in Python. So thank you for watching. Stay tuned for more of this. This is how you start data analysis jobs using Python. So please comment, please subscribe to my channel, comment, and tell me what you would like to see in the next tutorials. And if anything not clear of any aspects, please comment that as well. Thank you. Thank you for watching. Stay tuned. Bye-bye for now.